Okay, so what we're doing here is we're comparing the particle size of our substance D3 with the substance XYZ. And the way we're doing this is we're going to grind them both up into the smallest particle size we can get them with the mortar and grinder right there. And then we're going to take it under the microscope, compare the particle size, and that will allow us to effectively compare the structure of the two compounds or the mixtures that are in our substances. And that will allow us to determine whether they're the same, whether they're different, and then from that point on we can move on. So what we're going to do next is just take it to the microscope after she's done, and then we're going to compare the structures of the two compounds.
Yeah, they're different.
Yeah, right? Because the melting points are different. It means
melting points are different. So the intermolecular forces in this one
are different than
are stronger than the intermolecular forces in XYZ, which may affect our other things.
Which will affect the other chemical properties.
But do you think like it could still do the same? It could still carry out the same effect?
I don't think so, because the structure will be inherently different if the melting point is different, right?
We can try it at
different structures could.
Yeah, we could lower the temperature and see, or higher, like increase the temperature to see where the other one will melt.
Right. We could.
Because there's a melting point range.
Yeah, there should be. Yeah, he's right. There's a melting point range, right? So like a 5 degrees or
right. So we don't need to keep that one.
Yeah, we can keep this. Yeah, we can take this one out.
We don't want that one to start evaporating.
So right now the concentration of the solute is too high, so it's off the scale on the graph. So now what we're going to do is we're going to have to dump out some of the solution we have right now, and then we're going to continue to add more methanol and water, and that's going to decrease the concentration of the solute we have.
What we've done so far is we took a gram of our solute, which is our substance D3. We added 10 milliliters of water to see whether it would dissolve, and if it didn't completely dissolve, then that means that would tell us that our substance is not is polar. But because it just partially dissolved, we added more ethanol, which is a non-polar solvent, and with that we could dissolve it a bit more. So what that tells us is it's one of two things. One, it could be a mixture of a non-polar molecule and a polar molecule, or it could be a compound which has polar properties and non-polar properties in the structure. So that's what we know so far from our data.
So since we got the data on scale, we can find out that it only absorbs UV light but not visible light, and that shows us that there's double bonds in the structure of our sample.